Hello, welcome to the CSM video walkthrough for week 5, problem 5, and today I'm going to be going over Mario number. So this question is pretty long, but there's an upside to this. It allows us more opportunity for us to be able to translate the English into recursive ideas. So whenever you're walking through a long problem like this, it's always good to mark what the specific English could be or couldn't be in terms of recursion. So let's do that with this question. Now, Mario needs to get from one end of a level to another, but there are deadly piranha plants in his way. Mario only moves forward and can either step, which is moving forward one space, or jump, which is moving forward two spaces from each position. All of us represented as a series of ones and zeros, with zeros denoting the location of piranha plants. Mario can step on ones, but not on zeros. Now, the question is asking us how many different ways Mario can traverse a level without stepping or jumping into a piranha plant. And they want us to assume that every level begins with the one, and also ends with the one. So the hint asking us, does it matter whether Mario goes from left to right or right to left? And they're asking us which one is easier to check. So I think this is the case because intuitively it might be easy to assume that Mario is moving from left to right because that's how he moves in the game. But actually in code, it's very hard to parse numbers like this, especially with the tools we are already used to, which is for division and modulo. Yeah, and because every level actually ends and begins with a 1, we can just go from right to left instead and use our familiar tools to work with these numbers. Yeah, I should return the same solution. So we should make our lives a little bit easier. Okay, so let's actually get into the actual problem now. Immediately, I'm thinking we should be using tree recursion. This problem clearly lines out that each position, he can do either two things. So we have to check every single way that he can get down to a level or run into piranha plants, whether it be step, jump, step, or jump, step, step. There's so many ways that he can go. So the easiest way to do this is through tree recursion and just branch out and check every possible combination. Okay, so when I handle tree recursion, I like drawing a diagram to kind of see what's going on. Okay, so let's start with this first doc test, 10101. And we know that at every position, he can either take a step or he can jump. So how do we denote taking a step? Well, we know that taking a step is moving forward one space. And if we move forward one space, that means all that is left is the rest of the level. So like let's say you're standing on a square and you want to take one step, and once you get to the second square, that past square doesn't matter anymore. We don't need it. Yeah, it's gone. So we can kind of translate this into code. By taking a step, we're essentially just getting rid of one number because he has stepped over it, he doesn't need it any longer. And so if he takes a step, we are left with the rest of the level. Likewise, if he takes a jump, it's just getting rid of two spaces. And he doesn't need 0, 1 anymore. That's gone. He's jumped over it. Okay, so after every recursive call, we check for base cases and see if it's successful or unsuccessful. So for this step case, we know that this is unsuccessful because he has unfortunately ran into a piranha plant, and we cannot count this traversal into our final tally. So we should return to 0 because this attempt was unsuccessful. On the other hand, it's a 1 here, so he is safe. He's ready to keep going and try to make it to the end of the level. So again, we can step and jump in this position. If we step, we're only getting rid of 1. The rest of the level is 10. And if we jump, we're only getting rid of 2. So 1 is left. Okay, here again, we see that he's unsuccessful. He has run into a piranha plant. So the jump step traversal is unsuccessful. On the other hand, jump is successful because level has ended up back to 1. And we know that every level ends with a 1. So that means Mario has successfully gone to the end of the level, and we can count this in our tally as how many times he can traverse. So, and we see that this matches up with our doc test answer. Okay, now the final step we have to consider is how do we combine all of this together? Well, this is actually very similar to the counting partitions problem because it is also asking you to count the number of times that something can happen. And in counting partitions, we're able to add both calls together. So I'm thinking that we should be able to do that here too. Adding is the most natural way to go whenever you're trying to count the number of ways that something can happen. Okay, let's try to translate this into code. Well, we can start with the base cases first. When we're successful, we know that level is equal to 1. He has made it to the end. And we can just return a 1 to indicate success. Okay, on the other hand, when he's unsuccessful, he has run into zeros at the end of the number. So a lot of people might think that it should be checking if level is equal to 0, but this is actually false because level can never be equal to 0 because level always ends with 1. So in order to check whether he has run into a piranha plant, we have to check for the last number of every level. So if level mod 10, which gives us the last number, is equal to 0, we can return a 0 and say that he's failed this traversal. Okay, and finally, the recursive case, which is arguably the hardest part. Well, first we just need to know that we have to comma our number somewhere. So let's add that in. Okay, and we know that there's both a step case and a jump case. So we have to denote this in code. I'm going to say this recursive call is going to be my step case. And another one here is going to be jump. So for stepping, we know that we're going to get rid of the last number because that part of the level is no longer needed. And how to get rid of one number? Well, we can always floor divide. And if we floor divide, it's going to give us the rest of the number except for the last one. So this can denote us taking a step. So if we floor divide level by 10, we're going farther into the level by 1 step. And now similarly, jump is just getting rid of 2 numbers, so we can always floor divide again, or just a total floor divide by 100 to get rid of 2 numbers. So if we take level, first we have to call it again. If we floor divide level by 10, and floor divide again, this gets rid of 2 numbers and we've successfully taken a jump. And the final step in true recursion is to combine the cases. So like I mentioned earlier, this is very similar to counting partitions, where you're counting the number of times to do something, and so we should just add them together. Now this combination part may seem a little tricky at first. It's a little weird to add something that doesn't look like a number, but in reality it's actually turns out to be a number because the base cases will always return 1 or 0. So we can treat these like numbers and just multiply, add, divide, anything you need to do in the problem. In this case, it's best to add because we're counting something, but whenever you're taking this recursive leap of faith, it's always good to look at the base cases and try to treat these function calls like the base cases. So for example, if this was true, this is another problem, just saying hypothetically, this was true and this was false, you might want to do something like and or any or something that takes care of Boolean cases in the recursive call. Okay, so this is the end of the problem, and I hope this helped, and thank you guys so much for watching.